Let's begin Chapter 5, Lesson 1, Lines. We've already spent several days discussing angles and lines and angle relationships, and we've also talked about the fact that all of these geometry chapters are going to be very vocabulary driven in those. So these are some terms that you need to know. So first, let's take a look at our essential question. Remember, it is important that we know what our essential question is, so we know what it is we're trying to figure out in each chapter. Our essential question is, how can algebraic concepts be applied to geometry? So just when you think you're getting away from algebra and solving equations, think again. We're going to be doing lots of solving equations in the geometry chapters as well. So our vocabulary, which is also important, and you have your vocabulary packet, and some of these are probably on there. Most of them are probably on there. If not, we'll add them to our packet. Perpendicular lines, parallel lines, transversal, interior angles, exterior angles, alternate interior angles, alternate exterior angles, and corresponding angles. It's going to be very important that you learn what each type of angle is in order to answer the questions in this section. And if you do learn them, this section is going to be a lot easier. There are also some math symbols that we need to be aware of. You've probably seen these before. This symbol, the two lines, mean it's parallel. This symbol means perpendicular to. And when you see a little m before the angle sign and a number, it means the measure of angle 1. The Common Core standards that we're going to be talking about here are 8.G.5, and we'll use mathematical practices 1, 3, and 4. So 1 means we're going to persevere with problems, 3 we're going to construct an argument, and 4 we're going to model with mathematics. So those are all things we'll be doing in this section. Let's look up at the top and we'll look at our first two vocabulary words. It says when two lines intersect in a plane and form right angles, they are called perpendicular lines. Two lines are called parallel when they are in the same plane and do not intersect. Those are two terms that you probably learned several years ago in your math classes, so that shouldn't be anything new. So let's turn to page 372. Now 372 is where we really start in with some of the vocabulary that's going to be real important to know, and they're going to seem a little bit confusing at first, but we'll spend some time going through some examples together after you've watched the video, and you'll spend some time on your own doing them as well. So transversals and angles are our key concept. And we have different types of angles relationships that occur when we have parallel lines intersected by a transversal. So a line that intersects two or more lines is called a transversal. And when you have two lines, such as line I and K, and they are intersected by transversal line L, you have 8 angles that are formed. Here you can see them: 1, 2, 3, 4, 5, 6, 7, 8. Now sometimes they'll be numbered like this, sometimes they'll be numbered differently, sometimes they'll be designated with letters. So they're always going to be different. So you can't actually memorize the numbers, but you do have to learn the vocabulary. So interior angles mean that they lie inside the lines. So if you look at, we have line I and line K, and the angles that lie inside those two lines are angle 3, angle 4, angle 5, and angle 6. Exterior, remember, means outside. We've talked about that. So exterior angles are going to lie outside the lines. So here's line I and K, and the angles that are outside are angle 1, 2, 7, and 8. Alternate interior angles are interior angles that lie on the opposite sides of the transversal. So the first thing we need to remember is interior means inside, and alternate means opposite sides of the transversal. So here's the transversal. We're talking about these angles on the inside, and we're talking about the ones that are on alternate sides. So we have angle 4 and angle 6, and we have angle 3 and angle 5. And what we know about those angles is that when the lines are parallel, their measures are equal. So anytime we have parallel lines, interior angles, alternate sides of the transversal, they're going to be equal. Alternate exterior angles then obviously are going to be the angles outside the lines that lie on opposite sides of the transversal. Again, when the lines are parallel, their measures will be equal. So we're looking at angles 1 and 2 and 7 and 8. 1 and 7 are on opposite sides and they are equal, and 2 and 8 are on opposite sides and they are equal. Corresponding angles are those angles that lie in the same position on the two lines in relation to the transversal. This one's a little harder to understand, but if you can picture it, it's going to help. So if the lines are parallel, once again, their measures are equal. So let's take a look at the two lines. What we're looking for are the angles that sit in the exact same place on the same side of the transversal. So we have angle 1 is sitting on top of line I, and angle 5 is sitting on top of line K. Those are equal. Angle 4 is sitting below line I, and angle 8 is sitting below line K. So those are going to be equal. On the other side of the transversal, we have 2 and 6 lying on top of the lines. They are equal. And 3 and 7 lying below the lines, and they are equal. So here we've written measure of angle 1 equals the measure of angle 5. The measure of angle 2 equals the measure of angle 6. The measure of angle 4 equals the measure of angle 8. And the measure of angle 3 equals the measure of angle 7. Now remember, we've also already talked about vertical angles and supplementary angles, and those definitions are going to come in handy as well. So if you don't remember them, you may want to look back at your packet for that you have in your notes. All right, let's go on down. It says special notation is used to indicate perpendicular and parallel lines. Sometimes it might not tell us that they are perpendicular or parallel, but they're going to give us some information that will tell us that. So let's look here first. It says a red right angle symbol indicates that lines M and N are perpendicular. So we know that that little line or that little box means it's a right angle, and it also tells us that these two lines are parallel. We can write that this way. Or perpendicular, I'm sorry. We can write that M is perpendicular to N, and that's how we would read it. Over here, the red arrowheads indicate that lines P and Q are parallel. So when you see those little arrowheads like that, that means the lines are parallel, and it could be written P is parallel to Q. Let's look down at the bottom at some examples. Classify each pair of angles in the figure as alternate interior, alternate exterior, or corresponding. So let's take a look at them. It says angle 1 and angle 7. Here we've got parallel lines, and we have a transversal. So if we look here, we've got angle 1 on this side of the transversal and angle 7 on this side of the transversal. So first thing we know is that they're on opposite sides, so they have to be either alternate interior or alternate exterior, because corresponding are on the same side of the transversal. So we know right away that it can't be corresponding. So we're going to look and see, are 1 and 7 inside the parallel lines or outside the parallel lines? Since they're outside the parallel lines, they're going to be alternate exterior angles. Let's look at 2 and 6. Angle 2 sits on top of this line, and angle 6 on top of this line on the same side of the transversal. Since they're on the same side, we know they can't be alternate interior or alternate exterior. They have to be corresponding because they sit in the same position on the two lines. So let's go to page 373 and look at example A. It says classify the relationship between angle 4 and angle 6 and explain. So let's take a look at them. We've got three different types of angles relationships that we have learned about in this lesson. That's alternate interior, alternate exterior, or corresponding. So I have angle 4 here and angle 6 here. Here are my parallel lines. Let's just go ahead and name them M and N, and let's name our transversal T. So we notice that 4 and 6 are on opposite sides of the transversal. So right away we know they can't be corresponding because they're on opposite sides. So now that we know they have to be alternate something, we need to determine, are they inside the parallel lines, in which case they'd be interior, or outside the parallel lines, in which case they would be exterior. So we notice that they are inside, so they're going to be alternate interior alternate interior angles. And we know that alternate interior angles are congruent. So we know, or equal, same thing, measure of angle 4 equals the measure of angle 6. They're alternate interior because they lie on opposite sides of the transversal. And inside the lines. So if that came easy to you, that's great. If not, remember we'll be doing some more of them together in class. All right, let's take a look at the next section where it says find missing angle measures. This is not difficult, but you have to know these angle relationships in order to do it. So when two parallel lines are cut by a transversal, special angle relationships exist. We've already talked about that. We've talked about alternate interior, alternate exterior, corresponding. We also know about supplementary and vertical angles from our discussions before we started this section. If you know the measure of one of the angles, you can find the measure of all of the angles. So suppose you know that the measure of angle 1 is 50 degrees. You can use that to find the measures of angles 2, 3, and 4. All right, so if we know that the measure of angle 1 right here is 50 degrees, we've already talked about the fact that if two angles lie on a straight line, they're supplementary, and supplementary means that they equal 180. So if this one equals 50, and this one we don't know, when they're added together they equal 180. So we have the measure of angle 1 plus the measure of angle 2 equals 180 degrees. We know the measure of angle 1 is 50. We don't know the measure of angle 2. But we know that when you add them together, remember unknown is a variable, when you add them together we know they equal 180. We can solve our equation by subtracting 50 from both sides and we get x equals 130 degrees. So now we know that angle 2 is 130 degrees. Once we know that, we also know that angles that lie on opposite sides like this are going to be vertical. So if angle 2 is 130, then angle 4 is 130. And if angle 1 is 50, it's vertical to 30, or to angle 3, so angle 3 is also 50. So that's all that you have to do. You're going to have two different measurements anytime this happens. You're going to have most often an acute angle and an obtuse angle, and each acute angle will have the same measurement and each obtuse angle will have the same measurement. Let's take a look at the example below. It says a furniture designer built the bookcase shown. Line A is parallel to line B, so here's A and B and we know they're parallel. If the measure of angle 2 is 105 degrees, let's go ahead and write that down. Find the measure of angle 6 and the measure of angle 3 and justify your answer. Well, we know that we can show our work by saying that measure of angle 2 plus the measure of angle 6 equals, okay, we know they're on a straight line, so we know they are supplementary, they equal 180. So we'll write that over to the side. We know the measure of angle 2 is 105 plus the measure of angle 6 we don't know. We'll subtract 105 from both sides and we get x equals 75 degrees. Now, did you really have to do the work to show that? Not really. You could have said 180 minus 105 is 75, which is what we did right here. But algebraically, we need to know how to solve it as well. So I do want you to make every attempt to solve them algebraically. So now we know that the measure of angle 6 is 75 degrees because they are supplementary angles. Now we need to find the measure of angle 3. So measure of angle 3, here is 3. We know 6, and if we look, they sit on opposite sides of the transversal inside the parallel line, so they're alternate interior. Alternate interior angles are congruent or equal, so we should know that the measure of angle 3 is also 75 degrees. Now, that is all explained to you right here in the explanation. You can look at that again if you need to. Let's look down at example B. It says refer to the situation above, find the measure of angle 4, and justify your answer. Well, there are several different ways that we could do that. We know that angle 2 and angle 4 are corresponding, right? Because they sit both beneath the lines on the same side of the transversal. We know that corresponding angles are equal or congruent, so we could say they are corresponding, therefore angle 4 is also 105 degrees. Hopefully you also noticed that 4 is supplementary with angle 3, so we could say angle 3 and angle 4 equal 180 degrees. So if angle 3 is 75, angle 4 will be 105. So either way, let's just say we'll put down one of them, and let's say angle 2 and angle 4 are corresponding. So the measure of angle 4 equals the measure of angle 2, and the measure of angle 4 equals 105 degrees. So you could explain it in a different way. Everybody may look at it differently, but that's probably the easiest way to explain it. All right, let's go ahead and turn to page 374. 374 has an example that is a little bit more difficult at the top of the page, and I'm going through it with you, but we probably won't spend too much time doing these really difficult ones right now. It says in the figure, line M is parallel to line N, and line Q is perpendicular to line P. The measure of angle 1 is 40 degrees. What is the measure of angle 7? So we know that this one is 40, and if I look, I can see that 1 and 6 are alternate exterior. That means that 6 is also 40. And then if I'm looking on this straight line, I see that 6, 7, and 8 make a straight line. So all of them together must be 180. We know that 6 is 40. We know that 8 is 90, and we don't know the measure of angle 7. But if we work it out algebraically, we can figure out that the measure of angle 7 is 50 degrees. Some of you are going to be able to do that really well. Some of you are going to have a harder time, but we'll work on those together in class. So that's the end of lesson 1, chapter 5. You do not need to do any of the work on the guided practice today. We'll do that together in class tomorrow.